We are dismantling a Hithium lithium phosphate cell 280 Ah to take a look at its internal structure, whether it is a lamination technology or a winding technology. The testing battery cell is from a broken battery pack. It is not workable. We took out the coal from the aluminium shell, and when viewed from the outside, it was two parallel coal. Let's zoom it and first cut it. The liquid flowing on the ground is electrolyte. Electrolyte plays a role in conducting ions between the positive and negative electrodes of a lithium battery, ensuring that the battery can achieve high voltage, high specific energy, and other advantages. At this point, the electrolyte is leaking, so there is a pungent odor. Electrolyte also has the characteristics of being flammable and explosive, so it will burn when there is an open flame in the past. The aluminium shell is used as other outer shell for the most lithium-ion battery in the market. Now remove the attached white film. Remove the upper plate. This is negative pole. What is this? This is the negative copper. This battery is NMC battery, which with the positive electrodes made of the lithium, nickel, cobalt, manganese oxide attached to the aluminum foil. This battery is used the lamination technology, which involves a separator. The negative electrode is then the positive electrode, with a separator in the middle, stocked one by one. Look, it is stocked one by one, not the row. For a row, it is the Hithium. The Hithium 280 Ah is using the winding technology. This one is NMC 147 Ah, but it is not filled with electrolyte, so there is no electricity. So it is very safety when we open the case. Then with the first disassemble, you will find there has two pieces of 140 Ah coils connected in parallel. The copper is negative, aluminium is the positive. If there are conductors connecting them now, a short circuit will occur and will get fired. When we completed open it, we can see there is a winding process inside, winding it in circles. When we completely open it, the white one is the diaphragm, and the black one is the negative graphite. The knife is iron, and iron is conductor, which can catch fire. There is electrolyte between each diaphragm, positive, negative electrodes. If the electrolyte evaporates, the battery becomes non-conductive. Place the metal blade between the positive and negative electrodes as there is electrolyte exists. It still catch fire. Due to the loss and volatilization of electrolyte, the battery gradually becomes non-conductive and its charge gradually decreases. Look, you can see the smoke here. That is get fired. We use a tester to measure the voltage between the positive and negative poles. And at this point, there's still 3 voltage between